right, we've entered our last unit on exponential and logarithmic functions. All right, so we're getting close. All right, so in this notes, we're going to go over graphing exponential functions. And as you can see from the very beginning of the notes, an exponential function is a function in which the variable is in the exponent, and it gives you a few examples. There's also some real-life applications that involve these exponential functions, which you can read about here. And I'm going to focus first on showing you the parent function, the two different versions of them, how things might be a little bit unique, and then we'll do some practice ones. Okay, so if we have our base, right, so this b base is greater than 1, this represents exponential growth. Excuse me. Okay, the domain for this function is going to be negative infinity to infinity. You can plug in any value you want. The range, as you'll see when we graph, is going to be 0 to infinity. The x-intercept is going to be none. We actually have a horizontal asymptote at that x-axis. The y-intercept is 0, 1. And as I mentioned, we're not going to be able to ever touch 0. We'll get closer and closer, but we'll never get to it. Okay, the end behavior is as you approach negative infinity, the function is going to approach 0. And as you approach positive infinity, the function is going to approach infinity, right? Because as we grow exponentially, we get increasingly larger as we move to the right. Okay, so let's try this parent one here with a base of 2. All right, so I'm going to do 2 to the negative third power, 2 to the negative second power, 2 to the negative first power, to the 0 power, to the first power, to the second power, and then finally to the third power. Now the ones to the right are probably the easiest to do. Anything to the 0 power is 1, 2 to the first power is 2, 2 squared 4, 2 cubed 8. These are a little bit tricky to the left of 0. The way you think of it is 1 over 2 to the first power, 1 over 2 squared, 1 over 2 cubed. So that's going to be 1/8, 1/4, and 1/2. All right, so if we graph this, we're going to have 0, 1, 1, 2, 2, 4, 3, 8. And then this one's a little bit tougher to see, but we're getting closer and closer to that horizontal asymptote, which is at y = 0. Now, I will say, usually I do end up graphing it in that way where I kind of like move to the left. But if you take a look as we read it from left to right, you can see moving left to right, the y values are getting increasingly larger, right? They're growing exponentially. All right, so that is a parent or a version of the parent function for exponential growth. Okay, let's do one with decay. So if your b base is between 0 and 1, this represents exponential decay, or the values are going to get smaller and smaller as you move to the right. So for this one, the domain is going to be the same, negative infinity to infinity. The range is also the same, 0 to infinity. We still do not have any x-intercepts. Our y-intercept is also 0, 1. We have that horizontal asymptote at y = 0. But this time the end behavior is a little bit different. As we move to the left forever, now our function is going to be moving towards infinity. And as we move to the right forever, our function, I don't know why I put 0 there, so I'll apologize on that one. As we move to the right forever, the function is going to approach 0. Okay, so we can do this parent function with a base of 2/3. All right, so I'm going to do 2/3 to the negative third power, 2/3 to the negative second power, and then keep going. Now, I'm going to do the ones to the right again. They are a little bit more straightforward with those positive exponents. Anything to the 0 power is 1, 2/3 to the first power is 2/3, 2/3 squared is 4/9, 2/3 cubed is going to be 8/27. Now, when you have these negative exponents here, what we're going to do is we're going to take this base, this fraction, and we're going to do the reciprocal, so 3 over 2, and that will allow me to make the power a positive. So 3 over 2 cubed, 3 over 2 squared, and 3 over 2 to the first power. So it's going to be 3 halves, this will be 9 fourths, and this will be 27 eighths. Okay, so I'm going to plot these points here from my one of my parent exponential decay graphs. So 0, 1, and then I have -1, comma 3 halves, which is 1.5, -2, 9 fourths, which is 2.25, and then -3, 27 eighths was just under 3.5. All right, when I plug in 1, I get 2/3, and this is going to get closer and closer to 0. So how this works is we're going to have that curve is getting closer and closer to the x-axis as we move to the right. All right, so here is my horizontal asymptote. All right, so that is it for the parent functions, some basic examples for exponential growth and exponential decay. Let me give you some not so common outcomes and ones that we're not really going to explore in this class, but might show up at some point in your math career. So we're going to focus on our base being positive and then not 1. So the base will either be greater than 1 or it'll be less than 1, but it'll still be positive, right? So between 0 and 1. All right. So what happens if the base is exactly 1? So it's really 1 to any power, right? And that's always equal to 1. So this is going to result in a horizontal line. And if I were to sketch a graph of it, it would be that horizontal line at y equals 1. Okay? What happens if b is exactly 0? Got a couple options here. If you have 0 to a negative power, that's really like you're doing 1 over 0 to that positive power, which we can't have that 0 in the denominator, so that's going to be undefined. If you have that 0 to a positive power, right, that's just going to be 0 written however many times multiplied by itself. So that's going to be equal to 0. So it's a horizontal line, but it's a little bit different. Right, so it's the same idea, but we don't have values until we actually have a positive power, which will start here and then move to the right at 0. All right, this last one here, what happens if b is less than 0? So we cannot have a negative base. So if we have an odd power, that means we're going to have a negative answer. And if we have an even power, then we're going to have a positive answer. And what happens is you end up getting this like zigzag effect. And I'll show you what I mean. So basically how it looks is you have like kind of looks like dots like this. All right, so that's what happens when you have a base that's negative. Again, we're not going to have that happen in this class, but just, it might happen sometime later on in your math classes. Okay, let's do some general rules, look at our transformations, and then try some together. All right, so we've got some general rules to identify growth and decay. All right, some of them are pretty straightforward. So again, if your base is greater than 1, okay, so base greater than 1, that's going to be exponential growth. If your a value, so in front of that base, is also a positive, then you get your most basic exponential growth, which looks like the parent function we graphed. Now, if you change a to be negative or less than 0, that means you have a reflection over the x-axis. It is going to look like this. All right, but both of those are still exponential growth. For decay, like we talked about earlier, your base is between 0 and 1. Okay, but then if your a is going to be positive, that looks like the parent function that we graphed earlier. And then if your a is negative, right, so less than 0, that's going to be reflected over the x-axis, so it looks like this. All right, and we'll have kind of all these variations for each of these examples. So just remind yourself, hopefully you don't need a big reminder here because we just talked about these with our radical functions, but we are going to see all these transformations, and the way we're going to practice these is by plotting, or at least making a table of the original points, and then using our understanding of the transformations to plot what it would look like. All right, so we got 4 of them to do. All right, I know it gives you 2 options here for procedures for graphing, but I'm going to focus on this video on option 1. Okay, let's graph the following. So I'm going to first do a table for x and 2 to the power of x. So I'll do -2, -1, 0, 1, and 2. 2 to the 0 power is 1. 2 to the first power is 2. 2 to the second power is 4. 2 to the negative second power is 1/4. 2 to the negative first power is 1/2. Now, my new function, when I look at this, is I'm going to have just this negative that's in front of the x. So I'm going to make all of my x values the opposite, but not change any of the y values. So I still have the same y values, but all my x values become the opposite. Let me try that again. Here we go. All right, so I'm going to plot these new points of 2, 1/4, 1, 1/2, 0, 1, -1, 2, and -2, 4. And what I'm hoping you'll see is that this is actually a reflection over the y-axis from our basic exponential growth function. Okay? So the horizontal asymptote, the way I always do this is look, if it's written in order, look right here, and there's nothing there, so it's kind of like a +0. So your horizontal asymptote is going to be y = 0. Okay? All right, let's do the next one. All right, our base this time is 3. So let's go ahead and write down a table for 3 to the power of x using those same x values. All right, that's to the first power. That's 3 to the first power, 3 to the 0 power is 1. 3 to the first power is 3. 3 squared, 9. So this is 1/9 and 1/3. All right, we're going to move it, though. And when I look at my transformation, I see it's with the x in the exponent, and it says -4. So this is where I've tried to tell you guys when it's inside, like the absolute value, inside the radical, we want to think opposite. I know it's not inside anything, but it is in the exponent. So we're going to think opposite, and we're going to add 4. Okay? All the y values are the same. We're not touching those. I don't see anything after the base raised to that power. So adding 4 is going to be 2. That's going to be 3, 4, 5, and 6. All right, so let's graph these here. So 2 1/9 is getting pretty low there. 3 1/3, a little higher. 4 1, 5 3, and then 6 9 just off the grid there. Now again, when you look at this, I don't have anything written after that base to a raised to an exponent, so I'm not going to have any difference yet in my horizontal asymptote. It's still going to be y = 0. So make sure you're not going past the x-axis. So this is still y = 0. Okay, so that's an exponential growth one, move 4 units to the right. Let's try 2 more. All right, number 3 is going to be decay based on that base to the base is 1/2, which is, when I look at that, it is between 0 and 1. So I'm going to do my -2, -1, 0, 1, and 2. All right, I'm going to do the positive ones first. So 0 power, that's always 1. This is 1/2, and this is 1/4. But remember, when you have a negative power, right, when I have 1/2, let me do it somewhere else. When I have 1/2 to the negative second power, that's really like writing 2/1 to the positive second power, which would be 2 squared over 4. And this is going to be +2. Okay, now we are going to move that. And we've got, looks like one transformation here. I've got that +3, which is going to change my y values by adding 3. All right, and it's also, because it's written afterwards, is going to change my horizontal asymptote to y = 3. So that is going to be new. So my x values won't change, but my y values are going to all be added by 3. So 7, 5, 4, 3.5, and then 3.25. So graphing this one, 2, 7, -1, oh, that's the wrong one, I'm sorry, -2, 7, there we go. -1, 5, 0, 4, 1, 3.5, and then 2, 3.25. And again, we're getting closer and closer to that horizontal asymptote at y = 3, right? That's kind of the first time we've had the asymptote has not been at the x-axis. All right, so just make sure you don't cross that horizontal asymptote. All right, so it's still decay, but we moved it 3 units up. Okay, let's do one more. All right, so I know it can be a lot trickier here because we have a lot going on, but I'm focused on the fact that it's just 2 to the power of x, which I actually had that earlier, right? I had this that I used in an earlier question, number 1. So I'm going to copy those original points. All right, now here's what I'm going to do to them. I'm going to have my x and my y. Let's see what I'm going to do. I'm going to do 3 to the left for my x values, right? Thinking opposite. I see this negative in front, which is going to multiply by my y values. And then the +1 afterwards is going to add 1. So everything's going to be changing here. So -2 minus 3 is -5. That's going to be -4, -3, -2, and -1. And now I'm going to do the opposite of my y values and then add 1. So -1/4 plus 1 is 3/4 or 0.75. -1/2 plus 1 is 1/2, which is 0.5. -1 plus 1 is 0. -2 plus 1 is -1. And -4 plus 1 is -3. All right, so let's graph this new one. -5.75. -4.5, -3, 0, -2, -1, and -1, -3. Let's get the horizontal asymptote. Right here is +1, so y equals +1. All right, and I'm going to finish my curve like that, and then going towards -infinity. All right. Okay, so that's 4 different examples that we did. That last one had the most transformations, right? It had 3 of them. We had 3 units left, 1 unit up, and that negative out front was a reflection over the x-axis. All right, so check out the video, you're watching it. Hopefully you enjoyed it. Check out the homework questions and come see me if you have any questions.